Hey guys, Mrs. Barker here. You should be on Google Classroom and you should be choosing Transformations Day 1, this Google Slides. I'm going to go through the Google Slides just like a normal note page because that's where the pictures came from, was a normal note page. You have two options. Your options are to just follow along in the Google Slides and fill in the answers to actually write your answers for the note page on the Google Slides. Or if you would like to get out a blank sheet of paper and a pencil, you are more than welcome to write your answers down there and kind of take some notes on a blank piece of paper. So it's your decision what you would like to do. Just go ahead and pause the video if you don't have your note-taking option pulled up, and then go ahead and press play once you're ready to start taking notes. All right, you guys. So we obviously are not able to finish up y equals mx plus b and graphing and writing equations of a line with a test since we're not here at school. So we're going to move on and we're going to look at the next unit for what we will be doing in math. So the very first thing that we're going to be looking at are...
Bill, please come to the main office.
All right. Hopefully that makes it feel a little bit more like school to hear the overcome. Anyways, so we are going to be looking at these transformations. So transformations are when we're taking an image, for instance, like this image, and we do different things with this picture, okay? An image is the result of a transformation of a figure. So we start with what's called a pre-image, and then we perform a transformation, and we end with the image, okay? Rigid transformations maintain congruence. So that means when I take this image and I perform either a translation, reflection, or rotation, this image does not change shape or size or dimensions at all. Lengths stay the same, points stay the same, the size stays the same, everything about it stays the same, okay? So let's look at what a translation is. You should be now on the second slide on your Google Slides. A translation moves a shape laterally, meaning left to right or up or down. So we are going to take a look at this picture, and on your Google Slides, if you're doing this on Google Slides, you should actually be able to pick up this image and move it down to this image. The question is when I took this picture and I moved it down here, did my angle stay congruent? Did my angle change at all? Well, if this shape, if all I did with it was pick it up and move it, I didn't do anything to that angle, so yes, that angle did stay congruent. How about this side right here? Angle side AB. Did side AB stay congruent as I moved it? Well, if I just took the picture and all I did was slide it over, I slid it to the right and slid it down, I didn't actually change the dimensions of this, so yes, this was congruent. This side stayed congruent. So performing a translation keeps and maintains the congruence of the shape. If you have any questions, I didn't put a spot for this on the Google Slides, but you are more than welcome to add a text box. Either write your questions down on a piece of paper and send them to me in an email. You can even send me a picture of your questions if you have a phone to take a picture with and email me that picture. Or you can just type your questions on the Google slide, turn it into me, and then comment on the post saying you have some questions you'd like me to answer, okay? The next transformation is called a reflection. So a reflection is a mirrored image over a line called the line of reflection. So pretend that this is your mirror. This line right here is your mirror, okay? That's my line of reflection, that's my mirror. I am going to take my shape and I want you to imagine that you've picked it up off the page and you are flipping it over to the other side, okay? That is a reflection. We're picking it up and flipping it. When we are reflecting, the distances of each point remain constant on each side of the line of reflection, meaning if point A, let's say this is 3 units away from the line of reflection, A prime will also be 3 units away from the line of reflection, okay? That distance is the same when we perform a reflection. So if I took this shape and I picked it up and I reflected it, did this angle change when I picked it up and reflected it? It didn't change, which means that yes, it did stay congruent. And did this side stay congruent? So even though it's on the other side of the shape because I picked it up and I flipped it over, that side length didn't change. So yes, it did stay congruent. So when I reflect an image over a line of reflection, it does not change the distances of the shape. The reflection keeps the congruency, okay? All right, feel free to write any questions down. Pause the video if you need to and come back once you're ready. All right, on to the next slide, or you can just, if you're writing on your paper, just make another little section called rotation, okay? A rotation rotates a shape about a point called the point of rotation. So I want you to imagine here, you don't need to draw this, but if you just look at this, 2, 3, 4, 5, 6, 7, 8. Can you tell what I'm drawing? I hope that kind of looks like a clock. Okay, imagine we've got a clock, and imagine that this shape is attached to the end of the second hand of the clock. A rotation comes from this point of rotation right here, this center of rotation, and it's actually called the point of rotation. From this place, our shape, if we pretend that there's a clock hand attached to that shape, or if we pretend that there's a string attached to the end of that shape from the point, as we rotate it, that's what our rotation looks like, okay? So our rotation came out here and went over here, right? We're going around the clock. I didn't draw my clock very good. But when we take that shape and we just rotate it around that point of rotation, if you can imagine clock hands doing that, we are wondering, does this shape change when I rotate it? If I take it and I rotate it over here, did this angle change at all, or did it stay congruent? Yes, it did stay congruent. The shape didn't change. And did this line, did this side, line AB, side AB, did that stay congruent? Yeah, I didn't change the dimensions of the shape by rotating it. Now be really careful with rotation. It happens from the point of rotation, not from the shape necessarily. So it's really tricky to see rotation sometimes because we think that we're taking this image. Let me kind of erase my clock so you can see what I'm drawing. It's tricky because sometimes we think of taking this image and just rotating it around itself so it almost would look like this. And that point of rotation would be right in the middle there. That means that we are turning it like a fidget spinner almost, like it's turning around a center of a fidget spinner. Rotations come from the point of origin, so that's why I like to think, or the point of rotation, and that's why I like to think of it as a clock, because it's coming from this point and then rotating out there and going around in a full circle with any rotations there, okay? Alrighty. That's it for this quick introduction. So if you go back to your slide, you should have finished working through the slides now, and you should be on this practice time. I want you to go to this very first practice and try to get a SMART score of 100. It gets a little bit tricky because sometimes the reflection happens over a diagonal. So if you're noticing that you're unable to see what's happening with the shape, try and draw a diagonal and see if it's reflecting over the diagonal, okay? Then these last 5 are just exploratory. I would love you to go try 2 to 3 problems on each of these practices, but this is the main one that I want you to try. That way we can do our activity on Tuesday. If you have any questions about this lesson or any questions about the practices, feel free to send me an email. Feel free to comment in Google Classroom. And I will do my best to answer your questions as fast as I can. Okay, thanks you guys.